Hi everyone, we're just going to do a review of what we've learned so far in class to prepare for the test. So the first thing that we learned was we went over, so I'm just going to write this as a review and have a pen and paper ready because I'm going to check this work. So the first thing that we reviewed was we went over what the natural numbers were, and if you remember, the natural numbers were basically 0, 1, 2, 3, and all the way. So basically any sort of number that we encounter in nature, and we just write it with this little fancy Latin sort of styled n. So that's the natural numbers. The natural numbers. Okay. The next type of next sort of number system that we went through was the integers, and basically what the integers are pretty much from negative infinity, but they're non-decimal numbers. So 2, 0, 1, 2, 3, 4, dot dot dot, and we call these the integers. So they're just non-decimal numbers, and just pretty much like the natural numbers. So if you sort of notice that the natural numbers actually fit inside the integers in the integer set. The next one we went through was the the rational numbers, and basically this was described as any number that can be described as a fraction of a over b, where a and b are elements of integers. So this little e here stands for element. So in other words, some examples of this would be, for example, like the number 2, or any integer for that matter, because 2 can really be described as 2 over 1. Other examples are half, 3 over 2, basically anything that can be put into a fraction where both the numerator and denominator are integers. The next number set that we sort of went through were the irrational numbers. So we did that as Q, but then we put a C, which means complement. So that means anything that's not a rational number. So examples of this are, say, pi, the natural number e, pi over 4, for example, because pi is an irrational number. So this is not a rational number because even though the denominator is an integer, the numerator isn't. So this is not a rational number. This is irrational. And basically the collection of the natural numbers, the integers, the rational numbers, all of these, and the irrational numbers, all of these belong to the real value system, or the real numbers. And the way we describe that was the natural numbers can fit inside there, and inside that is the integers. The rational numbers are inside there, and basically this whole thing fits inside the real number system. And this shaded part that I'm about to draw, that I'm drawing right now, this is basically anything that is not a rational number, meaning an irrational number, and this whole shaded part right here is just basically the irrational set. All right, so everything is part of the rationals. There's the rational numbers, and we can see basically how everything fits into that Venn diagram. The next thing we went over was, the most basic sort of linear equation ever, which is y is equal to mx plus b. So we said that m is the slope, right? And we said that that's the rise over the run, right? And the formula for that was y2 minus y1 over x2 minus x1. Okay? B was the y-intercept. Nothing really surprising there, right? And that's just the equation for a straight line. Now, if two lines are parallel to each other, right, meaning that means that they both, so for example, if this is m1 and this is m2, then they have the same slope. So m1 equals m2 if these two lines are parallel, which means that they will never meet. They will never have an intersection point. On the other hand, if two lines are perpendicular to each other, what that means is they meet at 90 degrees. So if this line, for example, has a slope of m, then this line, its slope is the negative reciprocal, meaning it's negative 1 over m. So, for example, if a slope has, let's say m is equal to, say, -2, its perpendicular slope, this sort of upside down t, just means perpendicular, is equal to its negative reciprocal, so its negative reciprocal would be 1/2, all right? So these two slopes are perpendicular to each other. The next one, well, basically just to give an example of how to sort of, let's say we have 2 points and a line goes through them, and say one of them is 1, 2, the other one is 3, 4, right? If we had to construct the equation of the line, first let's find the slope. So we know it's y2 minus y1 over x2 minus x1. We can call one of them x1, y1, the other one x2, y2. So just from this example, it'll be 4 minus 2 over 3 minus 1, which is equal to 2 over, 4 minus 2, 3, yeah, which is equal to 2 over 2, so it's a slope of 1. And so that's the slope, and now we need to find the equation of the line. So it's equal to y is equal to 1x plus b, so the only unknown is the y-intercept, which is b. So the way to find that is just basically you plug in a point, and then you see what b is. So in this case, say if I take this one right here, so y is equal to 2, x is equal to 1, and then plus b, so basically it's 2 equals 1 plus b, which, you know, if you solve it, b is equal to 1. So the equation of our line is y is equal to 1x plus 1. And that's how you solve basically the equation of the line given 2 points. The next thing we went through is the point, I called it the POI, which basically stood for point of intersection. Intersection, there you go. And there were 2 methods to find the point of intersection. One was substitution, where basically you just take one value of x and or y and you substitute into the other equation. The other one was elimination. I'm just going to go over an elimination example right now, just to avoid some certain pitfalls. So say, for example, the equation is 3x plus 2y is equal to 5. And the other equation of the other line is 4y plus x is also equal to 5. So the first thing you need to check for is everything lined up. See, the x and y, this is not lined up. The y and x and the constants are lined up, but the other 2 variables are not. So the first thing we have to do is just line everything up. So we get 3x plus 2y is equal to 5. And then the second one is x plus 4y is equal to 5. Great. So now that we have things lined up, we want to eliminate variables. But in order to eliminate variables, they first of all need to be the same number but different signs, right? So for example, let's just say we want to eliminate the x's. We can't do it because they're different signs. They're the same sign. So what we have to do is we have to multiply this. So since we want this to be negative 3x, we have to multiply this by negative 3. So if we multiply this by negative 3, what we get is, let's get the 2 equations again, is 3x plus 2y is equal to 5. And then the second equation will become negative 3x, because x times negative 3 is negative 3x. 4y times negative 3 is negative 12y. And 5 times negative 3 is negative 15. So let's just scroll down just a little bit so I just have myself a little bit of room. And then what we notice is that we can cancel this out. What are we left with? 2y minus 12y. So basically we're just adding these together. So this is going to be negative 10y. And then we have 5 plus negative 15, which is going to be negative 10. And so if you divide by negative 10 on both sides, y is equal to 1. Once we have that, we need to substitute back into any of the original equations. It doesn't matter which one. I'm going to pick the second one. So if we do the second one, we get 4 times 1 plus x equals 5. So 4 plus x equals 5. And if you just solve this, you'll see that x equals 1. Right? So our point of intersection is then 1, 1. That's extremely important. So that's extremely important, 1, 1. All right. so moving on, how do we express horizontal lines? This was very important. Horizontal lines. So say, for example, I have my y-axis there, my x-axis there, right? So if I have a horizontal line, so say, for example, like this line like that, right? And say it goes through the y-intercept of 3, the way you describe horizontal lines is you just say y equals 3. That's it. Say you have another line right here, that's -1. This would be y equals -1. And the x-axis itself, really, if you think about it, it has a y-intercept of 0. So the x-axis itself is described as y equals 0. With that sort of same concept in mind, how do we do vertical lines? Vertical lines, right? So once again, we have a y-axis there, an x-axis there, and say I have like a vertical line like that that goes through the x-coordinate 2. The way we describe vertical lines is x equals 2. Say I have one over here that's -3. This would be x equals -3. And if we want to express the vertical line itself, that is the y-axis, that would simply, because it goes through the point 0, that's x, so this would just be x equals 0. The next important concept that we went over was domain and range. So this is a very important concept in mathematics, actually. So let's just revisit this example, domain and range, or an example. So I'm just going to draw this here. So that's my y-axis. That's my, this is a horrible axis. So let me just draw it neatly. So I have a line like that, and I have a line like that. Okay, great. So let me just get a different color. So let's take red, for example. Actually, no, I'll just take blue. Take yellow. Okay, yeah, indecisive today. So I have that, and then I go up there, and then I have a little circle there, and boom. Okay, so say and then I include that point. So say, for example, that point is 5. This point here is 6. This point here is 2. This point here is, say, 3. This point here, say, is -2. And this point here, say, is -2 as well. Okay, so the question is, what is the domain and range? So let's just start, I'm just going to move it down, sorry, a bit. So let's just start with the best way is sort of draw a number line, right? Draw a little number line, and then, so remember, domain represents the x's, right? So let's draw a domain for the x's. So is -2 part of it? No, I don't see any other part of it, so -2 is not part of it, so that therefore we have sort of an open circle there. So we go along, we go along, we go along, and then we notice right here, at 2, there's no other value, so there's another open circle right there, right? So there's a value of 2. And then we keep going along, and then 5 is included, so we include 5, right? So let's shade the parts that are valid. So from -2 to 2, we have that part, and then from 2 to 5, we have that part. So basically, the domain in this case, I'm going to write D for domain, is we write x is element of reals, okay? X is element of reals, and then we say it's from -2 to, we don't include -2, and x is all the way to 2, right? So we don't include -2 and 2 because it's not valid, like we have an open circle there. And then because we segment it into 2 parts, we have this part and the second part, we write or, and then we go from 2x all the way to 5. So this is our domain, okay? Now let's do the same sort of analysis for the range, okay? So basically let's look at the range. So we look here, -2 in this part is also not included, right? So this is -2. We keep going up over here, and we might think that this 3 is not included, but if you notice that it is actually part of this over here, and the range is all the possible values. So 3 is not in 3, even though it looks like it's not included, is still part. So this is actually still part of it. So I'm not going to write the number there, but I just want you to know that it's part of it. And then it keeps going all the way to 6, right? So if we ask ourselves what's included as part of this, it's basically everything from here to here, right? So if I ask myself what is the range, right, is we say y is element of reals, okay? And what we do is we're pretty much going from -2 to 6. So from -2, we don't include -2 because there's an open circle there. So we put y, and it's all the way including 6. Okay? Does that make sense? I hope it does. The next thing that we sort of went through was square root functions. Square root functions. Okay? So just to give an example, let's say 3x minus 2 square root plus 4 equals 7. So the first thing we have to do is we have to isolate the square root part. So we do that by subtracting the 4 on both sides. So we get 3x minus 2 square root is equal to 7 minus 4, which is 3. The next thing we do is we divide by 3 on both sides. If we divide by 3 on both sides, what we get is x minus 2 square root is equal to 1, right? Then what we do is we square both sides. So if we square both sides, we get x minus 2 is equal, oh, let me just actually use a different color for that part. So if we square both sides, we square this, and then we're squaring that, right? And let me just go back to white here. Great. So we square both sides, that gets rid of the square root, and so that's equal to 1. And so then if we move the 2 over to the other side, or add 2 to both sides, we basically get x is equal to 3, and that's our solution. Okay, the next thing we went over were the squares and the cubes. So it's really important to remember what the squares are for, like, you know, the ladder numbers, so 11 squared, 12 squared, 13 squared. So all I'll just write down is remember the squares, the perfect squares from 11 to 20, okay? Because those are the hard ones, okay? And the same thing for the cubes from 1 to 5, okay? We sort of went over that in the last worksheet. The next thing to remember is sort of binomial expansion. So for example, if I have 2x minus 5 squared, right? How do you expand this sort of in one step? So the way we do it is, remember, it's the first term squared. So it's like that, I shouldn't have a bracket there. Let me just remove that. I won't have a bracket there. So the first term squared. So it's basically 4x squared. And the last term will be the -5 squared, so that's plus 25. And the middle term is 2 times the first term times the second term. So 2 times the first term is 4x, and 4x times -5 is -20x, right? So just remember that for expansion. The next one was, say, I think it was, it was factoring. So let's do, say, for example, x squared plus 5x plus 6, right? So if you remember the method, which was you take the first term and you multiply it with the last term, right? So there you go. So that's m, which stands for multiplication. So 1 times 6 is 6. The middle term, the a term, the man sort of thing, remember, if you remember, is the middle term right here. So that's equal to 5, right? So then n stands for find 2 numbers that multiply to 6 and add up to 5. So the 2 numbers are 3 and 2, right? 3 times 2 is 6, 3 plus 2 is 5. What happens next is that this middle term splits, okay? Don't forget that. So it's x squared plus 3x plus 2x plus 6. And where did this 3 and 2 come from? Well, they came from the n right here. So that's how we got them, okay? I'm just going to extend the page just a little bit, just so I have some more room. That's equal to, right, so then what we're going to do is we're going to group the first 2 and group the last 2. What's common between the first 2? It's x, right? And what's left over is x plus 3. Because x times x is x squared, x times plus 3 is 3x. What's common between the last two? It's plus 2. Right? So usually you take whatever sign is here and you put that there and then look for what's common between the two. And then that's x plus 3. And these two should be the same if it's factorable. And so we can factor that out. So we have x plus 3. And what's left over is this x over here and this 2 over here. And that's basically the man method. The next thing I want to go over is Pythagoras. Pythagoras, if we recall, right, if we have a right angle triangle, it's extremely important to have a right angle triangle. And this is A, this is B, this is C. A squared plus B squared is equal to C squared, right? So say, for example, I have this is a classic 3, 4. You'll see what C is. C will be 5. It's 3 squared plus 4 squared is equal to C squared, and that's 9. So this is 9 plus 16 is equal to C squared, which is 25 is equal to C squared, and C is equal to 5. Okay, so that side is 5. So straightforward stuff. The last thing I want to go over is the SoHCA. So in other words, if you have a right angle triangle, how do you find the angle? So, so basically this is just trig, or trigonometry. And if you remember the acronym SoHCA, it'll be very, very useful on the test. So SoHCA. So this means sine, and this is opposite and hypotenuse. This means cos, which means adjacent and hypotenuse, and TOA, which means opposite and adjacent. So for example, if I have this kind of triangle over here, okay, and let's say this is 1, and this side is 2, and we have root of 3. So if I say wanted to use 1, which is opposite to this angle, and hypotenuse, then I would, because I have opposite and hypotenuse, I would use sine. So sine theta in this case is 1 over 2. And so if I want to find theta, it's sine inverse of 1 over 2, which if you plug it into your calculator would be 30 degrees. We can do the same thing with cos. So let's say if I wanted to use the angle that's close to it, in other words the adjacent and the hypotenuse, so in this case cos theta would be root 3 over 2, and theta is equal to, therefore, cos inverse of root 3 over 2, and if you check that, that will also be 30 degrees. And finally, what if I wanted to just use the opposite and the adjacent, right? So say, for example, we can just use tan in this case, so tan theta is 1 over root of 3, and in this case, if I do theta is equal to tan inverse of 1 over root of 3, right? And that is equal to 30 degrees. Great. So that's basically the review for the test, and I'll see you in class. Take care. Bye.